Section 4.2, Special Applications of Ratio and Proportion Applications. A cylindrical vent 10 inches in diameter must be cut at an angle to fit on a gable roof with a 4:5 pitch. This means that for the vent itself, the ratio of rise to run will be 4:5. Find the height x of the cut that must be made on the cylinder to make it fit the slope of the roof. See the figure. Okay, so we have 4 rise to 5 run equal to, see, this would be the run. So the run, all right, so the run on here, that's 10. So we would do, 10 inch. All right, that's the run. And over here we have an unknown rise. That's the number of inch rise, right? Okay, so cross multiply. That gives me 5x. All right, so 5 times x. And then I say 10 times 4, which gives me 40. And I undo the multiplication of x by 5 by dividing by 5. Whatever I do to one side, I do to the other. And that gives me x is equal to 8. So that is 8 inches. So this is 8 inches right there. All right, so let's say if you are paid $233.47 for 2.5 hours of work, what amount should you be paid for 33 hours of work at the same rate of pay? Okay, so one way to do this is to set it up as a proportion. So you would say $233.47 for 21.5, and I'm going to put 0.5 instead. We don't know how much they make. That's the whole point, right? Unknown amount of money for working 33 hours. 33 hours. Okay. So we remove the units if you want to. So, and then you multiply. So you say 21.5 times x, cross multiply would give me 21.5x. And then we say 233.47 times 33. So that gives us 21.5x is equal to 7,704.51. Then we'll undo the multiplication of x by 21.5 by divided by 21.5. Whatever we do to one side, we do to the other. Cancel, cancel. It gives me x is equal to 358.35 dollars. Just like that. Okay. So the bag of the flange shown in the drawing is actually 16 inches, and the drawing width is, its drawing width is 5 inches. Okay, what will be the actual dimension A if A is 3.75 inches on the drawing? Okay, so let's do this, right? So we'll have 16 inches right here. In the drawing, this is 5 inches. This is the flange, right? The flange right here. These are both flanges. I guess I should make that explicitly clear. Flange, flange. Okay. So this is the drawing one, though, right? Okay. So what they're saying is that the actual dimension, right, the one you don't know, right? So I guess I could put down that this is the actual flange, right? And then of course we're going to have actual this other one over here. Okay, and that's the one we do not know what the actual one is. But we do know in the picture it's 3.75 inch right here, okay? So let me draw another similar diagram here just to make sure that this is clear what's happening, okay? So let's say we have this situation right here, okay? And we also have this situation right here. Okay. So what they're saying is they don't know what this is, but they do know what this is, right? In real life, on the drawing, this is 5 inches. And on the drawing, this is 3.75 inches. So when we're setting up proportions, these are going to match, right? The 16 there, and I put it on top, and the 5 inches here, and I also put it on top on the other side, okay? And then we have this one right here, 3.75. That's a 7.5. I know it looks almost like it too. That's 3.75. Okay, and these go together, right? And then these go together, but I don't know what this one is. So that's the big question mark. That's the one I don't know. Okay, hopefully that makes sense. Okay, so when we say 5 times x, or x times 5, which is 5x, and we say 16 times 3.75. So we end up with 5x is equal to 60. We undo the multiplication of x by dividing by 5. And what do I do to one side? I do the other. That gives me x is equal to 12. Okay, so whatever this is right here, we know that's equal to 12 inches, right? Hopefully that makes sense. Okay, so if a 51 gallon, I don't know what I put, 51 gallon, all right, so if a 51 hot water tank holds 425 pounds of water, what weight of water will a 67 gallon tank hold? Okay, so we end up having 51 gallon holds 425. These two numbers go together, right? The 51 gallon and the 425 pound. Okay, now we set up the other one. Now the gallon here, we know that the other one is 67 gallons. Cool, so far so good. But we don't know how many pounds that holds. So I'm going to put an x there, the unknown, right? So we multiply across 51 times x, 51x. And then we also cross multiply here, which is 425 times 67. Okay, so that gives me 51x is equal to 28,475. And then we undo the multiplication of x by 51 by dividing by 51, and whatever we do to one side, we do to the other. And that gives me x is equal to 558.33. Okay. And now, normally they probably want us to round this to the first whole number, so let's round this to the first whole number. So the whole number is 8, to the right of it is a 3, so we're going to round down so that all goes away, and that means we end up with x is equal to 558, basically, approximately. That's what those little squiggles means, approximately. Okay, so a manufacturing company uses 30 workers to unload trucks. Each worker can move an average of 14 boxes per minute. A robotic firm has built a robot that can unload boxes at a rate of 21 boxes per minute. How many robots will it take to do the job of 30 humans? Okay, so they were going to replace all these people. Now, if 30 workers do 14 boxes a minute, then they do 420 boxes. If that makes any sense. So 420 boxes. So the question is, how many robots will it take to do 420 boxes? Okay, so that's the real question. Now, that's a little confusing, but this is the simplest way I know how to explain this. There are other ways to do it, but this is the simplest way that I know to explain. Okay, so the robot, one robot can move 21 boxes per minute. 21 boxes per minute. So far, so good, right? We want to figure out how many robots are necessary to move 420 boxes per minute. And you can put per minute there if you want to. So it's an unknown number of robots. Hopefully this makes sense so far. So we do cross multiplication. We end up with 21x. And 1 times 420 cross multiplication gives me 420. We divide both sides by 21. And that gives me x is equal to 20. So we need 20 robots to do the work of 30 humans.